Hello. Oh, hello. Here we are in yet another segment of our introduction. I didn't know that we had so much to tell you, and this is just the beginning. Don't you think this is an interesting story? How our planet formed? At least the crust formed as a minimum? No, you saw a ball of molten rock. It cooled off about 4 to 5 billion years ago, and it formed a crust floating on the mantle. And then it evolved. It got water coming in, right? Water was not there from day one. Maybe if the planet is 4.5 billion years old, then the water came in about 4 billion years ago. And after that, we started to form cellular lives, one cell organism on the bottom of the ocean, in the primordial ooze of our oceans. And I'm going to show you some links at the end of this video to underwater oceanic hot water vents. And it's quite sensational. We'll talk about it at the end of the video. But now you have a feeling that you understand that rocks are kind of like a renewable resource, because the mantle melts and forms oceanic floor. Ultimately, that gets pushed up above the surface by colliding continents, right? On an active margin, gets eroded, heats up. You get volcanoes intruding through it, forming plutonic intrusive rocks and volcanic rocks at the surface. So lava flames, like in Flagstaff, Arizona, you can see lava flows and cinder cones on the surface. I highly recommend you go there. It's very interesting. And you can see how those volcanoes forms cinder cones and lava flows in the most capricious forms when they cool off. If they cool off inside the crust, then there are intrusives, plutonic rocks, such as granite and granodiorite. Okay, that gets weathered and carried by water into the foreland basin. You could call this the foreland basin in front of the mountain belt, and deposited there, or it gets transported all the way to the, it's off the slide, to the sea. And it forms sediments. And the sediments form the continents together with the acidic, igneous, and volcanic rocks on the active continental margin. Aha! Okay, and then they get carried down in the subduction zone into the mantle where they heat up as part of the convection current. And then they come out on the other side at the mid-Atlantic ridges, at the mid-oceanic ridges, at where the convection currents break through to the surface and form submarine volcanoes. Now, that's a cyclical process, and so you can see that rocks and everything that's in it, even oil and gas, are renewable resources. You just have to think on a different scale than when you grow a tree, or humans, which lasts barely a split second. 50 years, 100 years? What is that on the scale, the time scale of this planet, the time scale of the universe? We are so insignificant, and at the same time, we are so full of ourselves. So basalts form ocean floor, starting at the oceanic ridges, The ocean floor subsides when it cools off and ends up going on the continental crust as part of the plate tectonic process. All those rock plates of ocean crust, of continental crust, they all float like plates on the mantle. In the 1950s, we had a guy named Wegener, and Wegener measured, I forgot how he exactly did it, but he came up with the contents of floating continents on the mantle. It was only in the 1950s that we recognized that. Yeah, we know so much, right? We don't have to learn anything, and we understand anything of climate and how the world works. No, we have no clue. Really, we don't have a clue. We're just like little tiny children that just start to learn. Okay? But the ocean floor subsides below the continental crust. And Wegener was ridiculed by all the other geologists. What a bozo! Who thinks that continents so heavy and big can float? Ha ha ha! But Wegener, against the scientific consensus, was right. And today we call that process of floating earth crust plate tectonics. Ha! You're learning and learning, right? And geologists certainly don't know everything. Far from it. And I, after 40 or 50 years in this profession, still learn nearly every day. Those videos we make in the field right now, I still learn, and I've been at these outcrops at least 4 or 5 times. And they were described by other geologists like Roger Walker in the 1980s. Oh, that's just a split second ago on geological time. So how do you think that we can know everything? We're just little infantile babies, and we're measuring temperatures in our atmosphere that have been evolving for 4.5 billion years in a universe that might be even older. And we think that measuring temperatures for 30 years or 40 years, or even 10,000 years, with a minuscule amount of accuracy, that we can use that to predict how the climate works and what does and what does not affect climate. We should be, how can we be so arrogant? I have no other word for it. Okay, next point. Plutonic intrusions and volcanic lava flows and ashes are eroded into boulders, sand and clay and deposited. Clastic erosional products, right? That's what we call these erosion products. Clastic, these broken, fragmented pieces of rock, sand grains, are deposited as fluvial and aeolian deposits on the continents, where they are reworked and ultimately transported to the sea. And then ultimately, now after many hundreds of million years, they get caught in a subduction zone and carried back into the mantle. That is a renewable resource. Okay. I'm reaching the end of this story, and so I'm going to go a few minutes over, because we have here the asthenosphere with the convection currents in it. There are the oceanic crusts, the mid-oceanic ridge, where stuff originates, cools off, and gets heavier and heavier and dives below a continent or lighter material, or under another oceanic crust, which is a little bit younger and lighter, in an oceanic trench or in an active margin. But what if the convection current happens to occur below a single continent? And the continent floats above the convection current, and then it heats up, and it might even break into parts, right? we call that breaking down of a continent a rifting zone. An example of that is the Red Sea area, where you have rifts cutting through the east side of Africa. Right? And on one side you have the Persian Gulf and the Red Sea. On one side you have Egypt, and the other side you have Israel, or you have Saudi Arabia on one side and East Africa on the other side. Right? And then develops an oceanic ridge, and the continents start to be pushed apart. Like here's the mid-Atlantic ridge. First we had Europe and Africa and North America, or South America and Africa. They were forming one big continent, Gondwana. And that lasted up to 150 million years ago, which we call the Jurassic, when the dinosaurs appeared, right? And they were all together. They broke under a convection current, right? Sometimes you might call that hotspot. And they start to drift apart. Like here in Africa is going on currently, right? We have the East African drifting zone there, right? There's ridge developing where these two continents, Saudi Arabia and Egypt there, and East Africa, what is that, Somalia, and so on, right? And Dubai, all this, oh, Dubai's, yeah, it's somewhere here. Anyway, they're breaking apart with the rifting zone, and then they start to develop a mid-Atlantic ocean crust ridge, like we have here. Then ocean floor starts to be distributed, coming out of the ridge, cooling off, and pushing the continents further and further away from each other. Yeah. And then here, on the other side of North America, you have an active margin with the Andes and the Rocky Mountains there, and volcanoes like St. Helens. And there you have two ocean crusts meeting and forming deep oceanic trenches near Indonesia and the Polynesian islands, right? There's Australia, and all those areas around this ring of fire, you may call it, are very tectonically active. You've got many earthquakes there. If you're further out on the continent, it's pretty stable. You don't get a lot of earthquakes, right? But here, there is another active margin, right? And that is where you get a lot of earthquakes in South America. So that is a story of how rocks are formed and how it is a renewable resource.